Okay, problem 12. If f prime of x equals 3 divided by x squared, and f of pi is 2, then f of the cubed root of pi equals one of these. And we know right here, if we have f prime of x, and we want to get back to the function f, we know that we can go from f prime to f by taking the antiderivative. Since f prime is the derivative of x, we'll take the antiderivative with respect to x, and we should get back to f of x. We might have some sort of arbitrary constant here. We'll take care of that when we get there. Okay, so let's start by taking the antiderivative, the indefinite integral, of 3 divided by x squared dx. And I never like dealing with these x squareds in the denominator, so I'm right off the bat going to rewrite this as the antiderivative of 3 x to the negative second, since I can bring that up as a negative 2 with respect to x. And now I have a rule here. We know this rule that the antiderivative of x to the n dx is going to be equal to, I add 1 to my exponent, x to the n plus 1, and I also divide it by that increased exponent, what that value is. And usually I have a plus c. We'll take care of that shortly because we won't have that in our answer. So we're going to do the same thing here. The first thing I'm going to do, I'm going to bring this 3 out to the front. It's a constant. Don't need it inside our integral just to mess things up. So this will be 3 times the integral of x to the negative 2 dx. And now I'll do exactly what I showed right here. I'm going to add 1 to negative 2, which gives me negative 1. And so I get 3 times x to the negative 1 divided by negative 1. And then I do have an arbitrary constant plus c, and 3 times that, it's the same thing as an arbitrary constant plus c. And I'll simplify this down a little bit before I go any farther. So we'll get negative 3 over x plus c. And this is going to be our f of x, and really we're not going to have to worry about that. We'll take care of that shortly. So f of x. And now we use our initial condition. We know what happens when x is pi, so we'll bring this in and try to figure out what this c has to be. So we know that f of pi has to equal 2, but we also know f of pi has to be this negative 3 over pi. So let's use that information, negative 3 over pi plus c also has to equal 2. And from this, we can see that c, I add this 3 over pi to both sides, c must equal 3 divided by pi plus 2. And I can bring that back in, so we have a much better function. Now that we don't have some arbitrary constant, we just have our function. It's determined. So negative 3 over x. And I can add on my c. I can bring this value in, plus 3 over pi plus 2. Now we can go on and say, okay, I need to find this value. That's what I'm looking for. So let's substitute this in for x. Let's evaluate the function at the cubed root of pi. And let's see what we get. So cubed root of pi in there. And there's only one x in my function, so I just put it in here. I get negative 3 divided by the cubed root of pi. And I still get this plus 3 over pi plus 2. They're not like terms. And they no longer make me rationalize the denominator, so I look and I see that it's not quite in this form yet, but if I were to rewrite this with the 3 over pi out front, I could write this as 3 over pi. Then write this term minus 3 divided by the cubed root of pi plus 2. I see that. I have my answer of B.